So far, we've just looked at loading things into memory, storing things in memory, and moving them about in memory. We've not really cared about alignment, which is an important topic. And so what does that mean? Let's get on to the topic and we'll see what happens. So MIPS has a byte addressable architecture, and what that means is any individual register and the byte that is stored there may be addressed. As we saw in the last lecture, you could just address any of the registers and pull the byte out using the LBU instruction. But that's not what every instruction set does. Some are word addressable, and that means you can only address complete words. And as we know, words are 32 bits of information, and they're stored at the register where the address is, and 3 above that. So it takes up 4 register spaces to store a word. And you can see this in the diagram here, that the word can only be addressed at every 4 spaces. So let's have a look at an example. What does this instruction do? So you want to load what's in Cocoa Cafe into S1, and using little endian notation you would expect that to be the word diseases, and it should go into to S1. But actually what happens is we don't get that. We get an exception saying that the address is not aligned on the word boundary, and that's because this has not been aligned properly. So let's have a look at another one. If we try and load this half word, and from Cocoa Caf you would expect that to load 5EA5 into S2. Again, that's not what happens. We get another error saying that the fetch address is not aligned on half word boundary Cocoa Caf, and that's because it's not aligned properly. So what does it mean for something to be aligned properly? Well, words and half words have to be aligned. Because a word takes up 4 spaces of memory, the addresses must be multiples of 4. Think about if we didn't do this, if we didn't align words on multiples of 4, then you would wind up with overlapping instructions, perhaps in your program counter or in your data section. Your data would overlap each other, and you would wind up with something that is just too difficult for you to actually read without getting nonsensical information. Similarly, half words must be addresses which are multiples of 2. And this makes sense because if you think a word is stored at every 4 registers, and that means there are 2 half words per word. So you can get the lower 16 bits, and then you can get the more significant 16 bits. And this diagram illustrates that. You can see that every address you can use the store byte command, and only at the addresses which are multiples of 2 can you get the half word out, and at addresses that are multiples of 4 you can get the store word load words out. And so I hope this makes sense. Let's have a little recap about what we've done this week. So along with some of the basic load and store instructions, we've learned about loading half bytes, storing half words, storing half words, loading bytes, storing bytes, along with the ones that we already have. So I hope this was useful for you. If you have any questions about any of the content in this video, please feel free to get in touch with me. Thanks.